Vacuum is today's perfect insulator. We use it in our cups and our mugs, and we're now starting to use it in our glass. Vacuum insulated glass is manufactured by taking two pieces of glass, putting them really close together, and then drawing a vacuum in between them, making it that perfect glass insulator. And it works wonderfully. It works better than really any other type of insulated glass that we have before.
Using a typical insulated glass with a low E, you're going to get about a 0.24 U value. Going to a VIG, we can get down to 0.06. So if you have a project that really has some high performance values on it, introduce VIG and you can probably achieve those values you're looking for.
Gun Hall had challenges that are both in common with other works from this period and also had some pretty unique challenges. The energy code changed in Massachusetts while we were working on the design of the project. The major change in the Massachusetts energy code is that in the previous version, existing buildings were all but exempt from meeting the envelope requirements of that code. The new code does not exempt existing buildings. It provides slightly different pathways for compliance depending on whether or not you're changing the use, but it set some prescriptive standards that we needed to meet. So that's when we began exploring VIG.
We didn't expect is what we found around the perimeter of the glass. There we found a short circuit. There we found condensation because that metallic spacer was drawing the cold through or across that glass surface into the aluminum framing surface, and the thermal model condensated. That's why we needed to introduce Hybrid VIG.
Hybrid VIG, like I said, is either vacuum glass on the outside with an inboard layer or the vacuum glass on the inside with an outboard layer of glass. And you can use them interchangeably. It really depends on how the low-E coating configuration wants to be. So there's a million different low-E coating options with glass, and they all do different things. So between the north and the south facades, there was different coating profiles, but able to optimize the solution for the vacuum glass, but achieve the different reflectivities on the north and south. We actually were able to put the vacuum glass on the exterior side, which enabled a more efficient production process for the vacuum.
I think there's a lot of buildings, some of similar historic significance to Gund or even greater, that can benefit from that process and the way we looked at that sort of intersection, that sandbox that we had to work in when you intersect performance and conservation, and say that we're really not going to make a compromise on either of those. I'm also excited for a lot of not very nice office buildings all over the country that have single pane glazing on them. That complete reskinning would be an immense task. Demolition would be an immense waste of carbon. To come in with a product like VIG and make it much better. I think this shows that there are viable technologies available to make what is a huge percentage of the built environment much better than it is now.